So moving from theory to doing, Team Ian Telego are going to show us how it's done. There you go, just like that. For the mic? Yeah.
Hey again, everybody. I'm Skeeve Stevens of IntelliGo. I'm the CEO, and Kurt here is the Operations Manager of Networks. This is the talk about, essentially, I guess I better give you an overview of why we're doing this talk. Actually, I'll give you a disclaimer first. The strategy that we have developed here is a primary aim. It's going to annoy some of the purists of the way we do some of the things, but we have a primary aim, and that is get people that don't know IPv6 very well, and the ISPs that we look after, doing IPv6. And we've been succeeding so far and getting a lot of sort of IPv6 connectivity out there. So what we do is, as a company, is we actually run ISPs. We've got about 30 or so ISPs in Australia across the board. We also are now operating outside Australia, in New Zealand, Fiji, Singapore, other small countries and things like that. And what I'll get to in a minute, and why we're doing that is the expertise in IPv6 seems to be very limited, and I do list what I've tried to establish as who's actually helping people do it. So there's a lot of experience in-house, but there's seem to be little experience out there that people can get. So what I'm going to talk about here is before Kurt talks a bit more technical, is about what is stopping ISPs implementing IPv6. At some of the conferences I've been to recently, APNIC in Beijing and some other ones, cost is talked to about a lot. In the discussions out here I've heard people keep saying it's all about the cost, and I keep going, it shouldn't be about the cost. I realise that in some very, very large organisations, Telecom New Zealand and so forth, that it is going to cost millions of dollars in the long run. But that doesn't stop the tech teams actually getting internal skill done. Because in a year from now, when your customers are actually demanding it and actually know what the hell V4 or V6 is, you want to have been using this for at least 6 to 12 months. Otherwise, your architects, level 3, level 2 going down, they need time. And it's going to take a long time to skill this up. And in Beijing, I had some of the smaller ISPs scared, and I took them aside and we were talking to them about giving them strategies of little ways that they could actually start doing it now. We're in a country here and in Australia that V6 is easy. I'm talking to other small countries where the government owns the carrier, and if the carrier hasn't done V6, then either there's only one government ISP and some babies, or there's a lot of ISPs below them, and they can't get V6 no matter what. So they've got to wait, or they've got to find alternate methods to play around to get skilled up. A lot of people think it's really hard. I don't think V6 is actually very hard at all. A lot of the larger ISPs in Australia, we've got one notable exception, which is NZNOG, which has now released IPv6 to DSL users that can actually handle it. And they've got quite a lot of users, as Simon Hackett reported into the IPv6 Summit in December. There's a lot of people getting onto that. But most other ISPs, and there are a lot of ISPs in Australia, hundreds, are not even thinking about this yet. And if the bigger ones can't do it, or not even talking about it, then the smaller ones, how do they think they can even do it? Especially with they don't have dozens of engineers, sometimes they've got 1 or 2 or 3. Knowledge is the biggest barrier. Techs are not always great at talking to our management, convincing our management and the guys that hold control of purse strings about getting the money out of them to actually spend a little bit of money and resources on this. With the engineers that we've been working with, a moderately experienced Cisco admin can be doing basic IPv6 in 2 hours and IPv6 in under a day. And that's pretty much knowing nearly everything they need to know. My example was I was so with V6. I had my engineers working on it, and I was like, okay, I picked one of my customers. We had control of their pipe peering, and basically was logged into that. and put the addresses in there, announce it, came back the next day, or 7 a.m. when pipe updates. It's like, okay, how hard is it to do BGP with IPv6? And it took, apart from the commands being slightly different with IPv6 in front of them and some access lists and announcements and things like that, it took me about 30 minutes to get the 8 routes that were on Pipe New South Wales at the time. But I'm sitting there going, next morning going, Kurt, have I done anything wrong here? Because it seems too easy. And he's like, no, actually, it is easy. I've been trying to tell you this for months. Like he's been just convinced me to go Juniper, which he's been telling me for 2 years. Takes a while. Takes a while for management to get these things. But if you don't start playing with V6 now, networking in a crisis, as we just were talking during the break, is going to kill you. It's going to hurt badly, and your customers are going to leave. People don't know where to start. It's really big. There are a lot of things, and even a lot of things that we've talked in this conference about network, so BGP and other things, and networks and routing. There's actually far more beyond just our network infrastructure that we've got to worry about, which I mention a little bit later. But start where you can't really break things in the lab, but the lab is boring as batshit. It's really, really not so great. The lab, you can sit there and go, here's an interface, here's some IPv6 addresses. They can ping. Okay, that was 5 minutes. Now how do I get any actually skills and experience in playing with things? It's labs are really boring. So one of the things I actually suggest, and most of my customers have done it, is I tell them to go and get it. Just like those, the US is great at the moment. It's like for $60 you can get a colo in the US which is dual stacked, which gives you like 2 terabytes of traffic or something. Not that you need that much, but that allows you, because network engineers do work in all sorts of aspects of the network, but it does let you start to play with Postfix MX and DNS and Apache and a few of the other things. Getting to know, and even OSPF and taking BGP feeds, some of them will actually give you a BGP feed to be able to play with V6 and things like that. And they'll always give you a /64 straight up. You can go for it. But at least it's something live. I mean, I still remember the first time I did my first V6 trace route. And you're looking there excited at the keyboard. When you're playing in a lab, you can't do anything. When you're actually seeing trace routing to IPv6 or v6.google or whatever it is, and it's going around the world and you're watching some of the other things, this is a new generation for us. This is fantastic. And there's still a lot of people, probably a few people in this room, have still not yet managed to do. With the lab, you can test some of the impacts of BGP, OSPF v3 on your interfaces, and you can build entire labs and replicate your network if you've got Dynamips. I say to people, start at the border. I believe that it can have a segmented rollout. Get it to your edge. If your provider is dual stacked, so if you're on Vocus or FX, and they will give you dual stacked, or just ask for your / whatever they do, 112 or so forth. Look at the routes. Doesn't mean it has to go anywhere. Look at it. Still let you start playing with trace routes, pings, seeing how your connectivity looks like to the world, which is sometimes very important to hosting companies and other companies like that, is if people are on V6, how are they getting to me? And who's it going through? Is it going a very long route? It is enabling Quad A records on some of the hosting going to actually degrade performance for me at the moment? When will that tipping point be? So people say no one's asking for it. It's because they don't know what the hell it is. Public awareness is practically zero. They don't know anything about the exhaustion, much less even know the terms IPv4 and v6. Your typical receptionist will know what an IP address is. The public knows everyone knows what that is. Even your 12-year-old kids or less at home have IP addresses on their Xboxes and everything like that. There is probably no one that doesn't know what an IP address is. My 80-year-old father-in-law knows what an IP address is. You say IPv4 and you've lost them already. So it's even some education. You want to educate them about IPv6. First you've got to tell them what IPv4 is. And that's what actually they're in. And that way they can actually start to understand. And they will soon. As soon as things start to happen, as customers start to demand it, then people will start to know what's going on. Little vendor support. This is still true, partially true at the moment with CPEs. That seems to be the biggest problem. We probably all know about that. But they're slowly waking up and things are starting to happen. All the major networking vendors have had it for a long time. My Canon photocopier has a V6 address interface. So a lot of the big vendors have been, that's at least a 5-year-old device. This is one of the things that's slowing a lot of us down, is carrier grade NAT or LSN, scale NAT, it's the same term. We're going to need that as ISPs to give us the 3 to 5 years or longer. It's debatable, it's all about emotion when it comes to that. To me, what I mean by emotion is that how do people feel about V6 and V4 and how long are people going to hold out? When is the tipping point between having my websites and so on V4 as opposed to V6? And when am I going to start to cut them down? China seems to have had success with CGN, with local hardware, Huawei and so on. There was an article a few weeks ago talking about they've got millions and millions of people behind it. So clearly it's doable. Cisco's just released this thing at the top here called the CGSE, which is a blade for the CRS1. If it's for the CRS1, it's going to be obscenely expensive. Apparently the ASR 9000s and 1000s can do things. The Cisco documentation, which is really a marketing document, says it's got gigabits of throughput of CGN. Not quite sure what that means. And they've also say their service provider product set supports CGN, which has got like 877s pictured in 1800s, which I'm not quite sure what that means. Probably just means eventually it'll happen. And ISC have released the AFTR, the Address Family Translation Router, which is to do exactly this. We're testing at the start of February, and I'll be at APNIC in Manila, and we'll probably talk about it then and see what's been happening. And I think there actually is going to be a lab or some testing of the AFTR in Kuala Lumpur. Not Manila, sorry, Kuala Lumpur. Even IT people that I meet day to day, just having lunch with people, what do you do? Oh, I'm in IT. Oh, cool, I'm in IT too. Oh, what do you do? Networks, oh, what do you do? Blah, blah, blah. Do you know about IPv6? No. These are integrators. So we've got people that run the ISPs, that's us. But then there are all these integrators out there. I'm not sure if you use the same term in New Zealand, but in Australia we call them systems integrators, running around look after corporate networks and so forth. In Australia there would be almost none. You can count them on maybe 2 or 3 integrators that have even started to get IPv6 skills. And these are the ones that we need to build our network, the supporting things on top of the networks. 2008 servers, infrastructure and everything else that they build, that know nothing about the underlying network or very little and don't really care, but they still have no skills yet and don't even understand what's going on. The national sales manager of a telco, that's just a sad example of, he was the national sales manager of a wholesale ISP, and I said, oh, when your V6 product's coming out? And he said, what is IPv6? And I was like, oh really? You need to talk to your engineers and ask them, and then maybe try to get them to explain it to your product engineers or designers, because that's just really sad. And that was only 6 months ago. Now this is really bad still. Who can help you commercially? Very few people. Well, there's probably a lot of V6 expertise in this house and here, but it's mostly in-house and inside your own company. You aren't running around helping your competitors. There's a lot of stuff available on the net, but there's still no Dummy's Guide to V6 in my ISP books. The communities is one of the best ways. OzNOG, NZNOG seems to be really great. Training courses. I don't know much about NZ, but I know IPv6 now does it in Australia. APNIC trains them around the whole region. Fastlane, Men and Mice, I think they're coming to Australia. Dimension Data and New Horizons do the Cisco Cert, and that's the price for a 5-day course. Now, your small to medium ISPs, you've got no freaking chance of affording $4,500 plus the cost of not having them at the office for one engineer, much less 5 engineers, or depends on how your business scales, that just gets even more expensive. And it's crazy. Consulting, well, that's what I'm saying, I said at the start, we're running around all over the Asia Pacific region at the moment because there is no one. So I know Nathan was doing exactly the same. In fact, Nathan Wood helped us develop this project that we're doing. So I brought him over to Australia to just go through, verify, make sure that we weren't clueless in a lot of the areas, which we were in some areas that he fixed up for us and everything like that, because it's quite a thing that it's a little bit offbeat, but so we want to make sure we do it as right as possible. So, but yeah, you know, everyone knows Nathan Ward here, Brain Trust and Prophecy. They've got the skills for it. Haven't done much of it yet, but it's also because no one's asking. But you want to find someone that's not necessarily a direct competitor as well. And implementation, because I believe there's a difference between training, giving advice, and actually logging into the routers and doing it. I don't know if there is NZ Cisco Professional Services. They may come from Australia, but we, Brain Trust and Prophecy, we've got the skills. We know the networks. We manage ISPs. We can do it for you, and we can help you out. And it also just makes that rapid implementation a lot faster. Okay, it's quite big. I'm not going to go into every step here, but we try to take it a bit slowly but quickly, which means you have to think about it compartmentalised, but you can do it pretty quickly. And now I'm going to hand over to Kurt, who's going to talk through some of our implementations and the technical side.
Very technical. So everyone hear me all right? Yep. Okay. The diagram up here on the display basically says it is big, it is hard if you just look at it as V6 and my network. But if you start to break it down to the individual components, we've got experiment externally like we discussed before, get a vHost in the States, let them deal with all the networking side of it, and you've got a host, play with V6 from just a networking host perspective. Get your allocation from AppNIC, relatively easy to get if you're already a member. If you're not a member, it's still not that hard to get V6 allocation at the moment. Bring it into your edge, through your core, to your desktop and hosting. To my personal belief is the hardest part of V6 is the end devices, the servers, the individual bits. Hop by hop networking doesn't change whether it's V4 or V6. I've got an IP address on this side, an IP address on the other side, and some table somehow that says to get from here to there, go that interface. It doesn't change. The topologies are completely separate as well, whether it's V4 or V6, doesn't make a difference. Everyone says, oh, IPv6, there's all this new stuff I have to learn, it's complicated, it's difficult. My opinion is half of the complicated and new stuff is all local subnet related things. Oh, how do I talk to this other device on the same subnet? How do I learn what my default gateway is, or all these other things? In terms of your network, hop to hop, it doesn't make a difference. It's relatively straightforward to set up, which is what we've got here. So as Skeeve mentioned before, we have a hosting customer, several, a couple of hundred racks and data center and transit. Now it helped. They already had pipe peering, and Pipe New South Wales, or Pipe all over Australia, offers V6 peering on theirs. And they also happen to have focus transit, so that was convenient. So first step, get their IP allocation. Got their V6 allocation, as I said, relatively easy. You can organise that in no time. BGP peering, get it to your edge, make sure the rest of the internet can get to you. Because, as we mentioned before, if you're doing it in a lab and you're trying to ping things and you get to the other device you set up, you already knew that you could talk to that device. You want to talk to all those other devices you didn't touch. So get into your network. So now it's at your edge. You're seeing BGP routes, all these things. I mean, an engineer who knows BGP, it's not that much more complicated, at least on a Cisco, to turn on, address family V6, add a couple of peers. The rules are the same. Your access lists might be slightly different, and instead of typing the IP command, it's now IPv6. But it's not complicated, the rules don't change.
Except Cisco puts all the V6 addresses at the bottom.
And they're not side by side, it is frustrating.
It pisses me off.
So, enable it in your core switches. We've got top of rack switches at this particular customer, 3560s, 3750s, and we were like, oh sweet, we've enabled the core. That was, what was that, like half an hour it worked out to be. Let's get it to the edge. And then you discover that your 3550s, your 3560s and your 3750s now require a reboot to change your SDN preferences. So it kind of slowed us down for a bit that first time. So you schedule the outages, make the appropriate reboots when you need to, and move on. So also OSPF v3, it doesn't run over your existing OSPF, it's a new OSPF v3, which also works really well because it's a different routing instance from a configuration perspective. It helps you visualize that they're two separate topologies. bring in new VLANs dedicated for V6, so you can try some, dedicated V6 VLANs versus dual stack VLANs, and then move it through to your actual individual platforms. Do I have Plesk or hosting? Do I have, mail servers, DNS servers? Basically, the things you're selling. Get the IP addresses to them, and then you can start to discover what doesn't work.
Because you can do nothing with your server infrastructure, operational systems, or anything if the network's not already done. And I mean, even Telstra or Telstra Clear and Telecom New Zealand should be able to V6 their entire core and then worry about everything else afterwards, because you're not going to be able to know what's going to break until you try and turn it on.
Yeah. And so, I mean, customers, some of the racks already had like a Cisco 3550, not capable of routing V6, which is a shame because they're a wonderful switch. But all you need to do is just route that VLAN or trunk that VLAN to a device that can, and only put V6 on that other device. There are ways around these things for experimenting purposes. So we got all the way to the now their customer's colo, and they're able to start assigning addresses to a customer. Even with outage notifications, the process was pretty quick. It took us less than 1 week to enable that from the core to testing to assigning, V6 subnets to end customers. It's not hard.
That's a dozen aggregation switches with about 30 to 50 topper rack switches handling different racks. Thousands of connections.
Yeah.
I think we should skip some
Look,
of these.
the next of these are all roughly the same, just talking about the various idiosyncrasies of content providers, aggregators, DSL providers. With the, do you want to take over here or do you want to keep going?
Yeah, okay. I'll give you back your tip. What we do is with our V6 development deployment, we've got some assumptions. Obviously, if we want to make it quick and very quick, you've got to have a few things ready. And that's like your allocation, a transit provider that's dual stacked, or tunneling close by, because you don't really want to screw around with that performance issues. We do prefer, obviously, a Cisco Juniper Edge. We can deal with some of the other things, or if you have engineers that already know their edges very well. We've worked on things like Quagga and other things, but we didn't have to so much concentrate on those. It was just like, can you do this, can you do this? It was even on things we're completely unfamiliar with. It was still easy to do the V6 when they supported it. Cisco Juniper, you don't hear much of HP ProCurve in this industry. We're working a lot with it at the moment, especially because it's cheapness in 10 gig. That's all native V6, all the new equipment, and Brocade as well. The engineer familiarity with their own network and the vendor hardware. Sometimes we've had engineers that didn't even know their own network. That's never funny. Try to have to spend that. You go, okay, this is going to take longer than than we initially thought, because we've got to spend 2 days documenting your own network for you. And that the transit and peering providers have actually made their announcements, because otherwise you're just going to be blocked until then. What's next? Okay. These are the sort of timeframes that we talk about. When you've got someone giving you a bit of guide, and this is the sort of thing that Phil and APNIC themselves in their training do often. And different to the IPv6 training from APNIC, I don't care about history. I don't care about where it all came from. I don't care about the maths. This is a rapid deployment where it's, let's start doing this right now. Let's not worry about the theory. If you want to go and do history lessons later on and actually do the proper training, that's great. But this here, the reason we're looking at this is there is a need. There's an urgent, pressing need. It's also not going to wait for the next cycle, 3 months away, for the training courses to come. We're about to run out. In a year or so from now, we should be using this for a year, which means you should be doing this now for the ones that haven't done it. There's some of the times. So next. And there's some of the times we've also generally build a test box on the network to give them something to play with and run web servers and test web servers and just run up a whole lot of scenarios, throw content on there, play around, see what happens. Jump back for a second. Access technology we treat as really a different discussion, because that's often very complex depending on the LNSs, LACs, and all those sort of things. We try to get people to do a readiness assessment. How much do they know of their network, operating systems, devices, everything they possibly have got? How much in-house skills? And then we look at their systems as well. So I'm going to go back to the simplified addressing, which Kurt.
Excellent, very nice. Thank you. Okay, basically, the main strategy that we have with the simplified addressing is we're coming from the perspective that your network engineers know their v4 layout. They're used to seeing their v4 addresses on interfaces. Most of them, because they're nerds, can recognise an interface because of the IP address. These are things that they're not, that aren't unfamiliar to them. So we've developed a strategy to take your existing things, it can be scripted, you can put it in an Excel spreadsheet to generate it if you want to, but it's a methodology to take interface X, dual stack this interface on either side of the interface, and start working with it. So it's all about, as Skeeve said, rapid deployment and get engineers using it now. We also believe, obviously, it's the quickest way. There are lots of things you can come back and learn later, history-wise, that you can deal with at the time. So basically, the strategy involves, you've got your IPv6 allocation at the front, 24.06.9800. We have then taken a block and we've gone, okay, we'll say F. It's somewhere up there. I've got plenty of space to come back and aggregate at the beginning if I want to have, maximum compression of the space with double colons. And what I'm going to do is I'm going to take my v4 address and I'm just going to turn it into individual blocks. Yes, it's no longer going to subnet the same way that .99 and 102, or colon 99 and colon 102, will no longer be 4 IP addresses away from each other. But from the perspective of putting interfaces where they need to go, it works. So internal addresses scale to the same thing, and they're now a globally routed address. In fact, if you're using 10.10 in multiple locations, well, as we said, instead of using F, use F0. In fact, you've got 65,000 of those blocks that you can scale this out as far as you really could practically need to go. We're using, as you'll see in the next example, we are using 120, like /128's individual addresses that will blow out your routing table at first, but with appropriate summarisation at the individual borders of either OSPF areas, BGP, however you've structured your network, that can be overcome. This is aimed at being a short to medium term solution. And so one thing we did discover, and it was late at night, Nathan and I were sitting at my desk trying to work out the intricacies of radius and DSL. And the individual blocks, we couldn't find a reference to what do I call that. In IPv4, we called it an octet and moved on. So basically we came up with the term, well, Nathan suggested the term Chaswazzer, and it's become really handy because nobody fumbles around going that bit between the two columns. And so far we've confused many people with that.
Yeah, the figure in government officially now uses Chaswazzer.
It's from a Simpsons episode. He's like, I call them Chaswazzers.
So there you go.
Let's go to Australia.
So we should get into the internet dictionary sometime soon, hopefully.
I mean, configuration is very simple. Loopback addresses, you're used to seeing your IPv4 address, it's a /32 on a loopback. With v6, we're taking the 1076.128.1 and we're just sticking on the front the 24.06.9800 : F address /128. On Cisco's, unlike what we're used to doing before, when you're using OSPF v3, you turn on OSPF inside the interface, turn on IPv6 on an individual interface basis. But as soon as I do that, I can ping that loopback address. It's fairly simple. The one catch-all, or the one got you in this scenario, v6 doesn't have secondary addresses. It just has lots of addresses on one. So if you're like me and you're always screwing up your configs and you go up arrow, oh, change that, enter, you come back and realise you've got 20 IP addresses on your interface, and that makes for some interesting troubleshooting at 2 o'clock in the morning. So make sure you move on. Same thing with this example is for connections with dynamic routing. I think it was Perry discussed on TechSig last night. With OSPF, it uses linked local addressing, so you don't need the IP address, a globally routed IP address, but we put one in there anyway for the reasons discussed last night, that it allows for trace route and pings and diagnostics to reflect the matching topology. And if you don't have a dynamic routing protocol, which I suggest you do, same situation. What we've done is we've taken a /1112, which is the last Chaswazza, and you assign, like in v4, one half of the /30 goes on one side and the other half of the /30 goes on the other. And you just create your IPv6, or in this case it's a static route, default route. Default route, other side of the network. It's just like v4 but with letters, it's outline columns. There's not a heck of a lot to it. So, and end users. What we've done for end users, after much debate in the office, we decided that we're going to give a /64 to a colo customer or an end user because it helps appease people who insist that it's got to be a /64 if you're giving it to a customer. So, okay, I can make that commitment. I've got a lot of /64s in my /32 anyway, so it doesn't really hurt me too much. And you do the same thing, IP address on either side, set a route for their static address across. And so this could be this guy's mail server, or in this case it's a VM head. 10.76.128.234 is the IP address on the other side. I'm just statically routing it the same way, or at least I statically route /32s in v4.
So one of the things this has got, it's got the added advantage of not just engineers on their own network quickly recognising what's going on, but even the end customer who might know their own IP goes, it's just a v6 version of my IP. Oh, that's really easy to remember. We are looking at this as a long-term solution. This is to get someone started and get them going quickly. And hopefully that over the 3, 6, 12, 9, 12 months that they've been using v6 and doing bits, they'll start to develop, and watching the internet, getting involved, they'll start to develop in their skills.
Once it's in your network and you're playing with it, you'll work out what systems work best.
Too many people can spend months just thinking about it, before actually doing anything.
I mean, in terms of spending forever doing it, yep, it's simple. As I said, you enable IPv6, well, go into conf mode, IPv6 unicast routing, tells your router that I'm now routing IPv6. Go into your interface, tell your interface that it's doing it, put an IP address, and ping. And it takes as long as it takes you to either type those commands or cut and paste those commands, and it's got some form of IPv6 on the device. So,
I guess we've talked about this one, but it's been mentioned before. Once you turn on IPv6, unless you do something, you're screwed, because everything is different. We've talked about SSH and Telnet. If you've got ACLs, protecting your SSH or Telnet sessions or however you manage your devices, all gone. You have to replicate every single bit of IPv4 security in v6. The only thing I found that doesn't work so far was NTP. I didn't think on Cisco's NTP could bind to v6 and everything yet, and so forth. Just what's next? Yep.
We are really close.
I know. I'll zoom through this bit. So basically, what we've done is we've gone through a lot of operating systems, applications, platforms to figure out what needs to be done. VMS, anyone at the bottom? That was only because when we met with the Fiji government last week, they were like, oh yeah, they turned off their last VMS box a month ago, which we found quite funny. And I said, well, you don't want that doing v6, do you? And then, so this is a typical test bed that we run through people, explaining either your server engineers or your network engineers, because network engineers sometimes need to be involved in the security in IP tables v6. It is so similar, and there's just a few gotchas you've got to get to along the line. Operating systems, common hardware. This is one of the things people forget. We're always talking about routing and networking, but IP cameras, biometric systems some things we've come across, getting them running, game consoles, video conferencing, VoIP handsets. I was happy that the Cisco SIP software, the new one just came out, was v6. And I was very happy that I wouldn't have to go replace a lot of Cisco phones. Photocopy, anything you can possibly think of, you're in a network. From UPSs, that's something that's in every racks. Management, so a lot of stuff. Okay, just some thoughts. If you have no access to IPv6 transit, you may have to tunnel, see someone that can handle it. If it doesn't, if your carrier doesn't do it, hassle them. Apparently Telecom New Zealand and TNZI will do it for you, Greg was telling me. If you talk to the right people, it's not productised, so you've got to talk to the right people, get it to happen, but it shouldn't be too far away. Same with your vendors. 6 months after all most of our implementations that were happening, most staff are talking to us in v6. Convincing management isn't that hard. Just tell them your competitors are offering it soon. Apparently Telstra is in Australia is going to be turning on transit in June, I think. So that's going to cause Optus to suddenly pop up and a few of the others that have been sitting on their thumbs for a while. Some parts won't happen overnight. There's some things that are a lot harder, such as DNS name servers and getting new registries. I don't know if Internet NZ looks after .nz can handle V6 clues and everything, can they?
Yeah.
Okay, well at least you've got that. We don't have much of that in Australia. In fact, I can't find a registrar that does in Australia that does US domains in Australia. Some of my predictions. That's just what I just talked about. I have an opinion about the gold rush. I love all Jeff's modelling and maths, but we know what the internet's like. We've just seen a whole bunch of presentations here about security, botnets, attacks, spam, and everything out there. And this is not a racist statement, but especially in Asia and Eastern Europe, they're a bunch of scumbags, a lot of them. So a lot of these ISPs, there is just a lot of crime out there, and a lot of these people are going to go, oh, so I can become a member or whatever, RIPE, APNIC, whoever, and they're going to start slamming IPv4 resources. And then when that starts to happen and a few things happen, a lot of us in the room, I mean, I've got a customer, I'll be honest, I've got an ISP customer that asked me to get a /18 for him, and I went, no, you've got 5 racks. Like, really, no. 2 weeks later, he's like, oh, can you put the /18 into my routing tables? He went and got it himself and lied. No justification whatsoever. And this is a normal, nice guy. People in this room will do this. We will get resources we don't need because it's free, easy right now. And with some of the figures that people are talking to me about what a C-class could be worth, 50K or $5,000 or $20,000. So I'm going to have a problem in a year or two because we build ISPs. People come to us, I'm going, yeah, here's your opening membership, IPv6 easy. So have you got 50K for a /24? And they're going to go, oh, because they're going to need it to still operate for the next 3 to 5 years, even a small amount of it. I think that's going to bring the exhaustion much quicker. The hype is going to happen. As soon as it hits the media, as soon as people realise, people will join up, people will start consuming. So those numbers, and especially other countries like if China and India start to do it, and a few of these other places, it's going to get really bad real quick. And a secondary market, I believe, will appear, and I think APNIC will lose control because there are so many ways around policies and things like that. A lot of them are paper tigers that can't do much. And it's just like spamming today and botnets. What can you do a lot of the time? Okay, here we go. Sorry, you had to put me before dinner, didn't you? Everyone's sitting there drooling, looking for food.
Well, we've got a couple of other.
Oh, we've got a V6.
Yeah, we've got a V6 thing, and Ali's going to show us how easy it is to get IPv6.
Not how easy it is to get IPv4.
Unless you want a /18.
Thanks, guys. Thanks.